All right, Algebra Squad, here we go. This is the 5.3 compound inequalities. All right, so before we talk about the compound inequalities, let's review the regular type of inequalities that we did in 5.1 and 5.2. So if we look at these two number lines that are right here in front of us, we could see two different graphs. The first graph is an open circle on the number -4, and then we could see that the line or the shaded area is going to the right side, where all the numbers that are greater than -4 are located. So the way that we would write this would be like this. X, or any variable, are my solutions because they are greater than -4. Now, some things to take from here. Number one, the reason why we have an open circle is because we are talking about the numbers that are greater than 4. We are not including 4. So we're not saying greater than or equal to 4. That's number one. And then number two, the second idea would be that we are shading to the right. All right, something else we want to talk about here, kind of just mention, is something that we learned about is that not only can we express our answer like that, but we can also turn it into what we call set notation. Set notation is pretty much a fancier way to express your final solution. And that is by using this little grouping symbol right here, the variable that you're working with. Set a little separator bar. So it's going to be in terms of X, my solution is where my X values are more than -4. Close grouping symbol. And there you go. That right there is set notation. All right, cool. Now, this next one over here, we could see that we have a closed circle at the number 3, and then the line is pointing to the left. So again, we know that it's a closed circle. We have a closed circle because of the inequality symbol that we're using. We are including 3 in our answer. It makes sense to say that 3 is not less than, but it is equal to 3. So that's good. Now, if you look at the one that we talked about up here, -4 is not more than -4. So that's why it wouldn't make sense in that one. And that's the difference between having an open circle or a closed circle that will make it true or false. All right, so what are compound inequalities? Like the English language, compound sentence is a sentence that has the word and the word or. Okay, so we're going to first start using or start practicing what is an and inequality. All right, what is an and inequality? It looks like the one that's graphed underneath here. So it's pretty much two compounds put together because they are going to have a shared region of solutions. So we can either write it like this, where our word and is pretty much in the middle, or we can get rid of the and word and put it all under the same inequality. All right. Regardless, the way that we graph it is the same way. It's very, very simple and self-explanatory. You could see in this one right here, if we focus on this, we have an open circle at -4 because of our inequality symbol. And it's saying that it's everything greater than, and that is why our shading is going towards the right here. Now, if we focus on this side over here, we could see that our inequality symbol is or equals to, has a little line underneath, and that's why we have a closed circle. And then we're saying that our answer is everything that's less than or equal to 3. And that's why this shading can seem, or we could say that it's going inward. So our solution is anywhere that is more than -4, not including -4, and less than 3, including the number 3. Okay, that is how we would say that answer. All right, so let's go ahead and look at this first example. Solve -8. Okay, I'm not going to read the whole thing. Then graph the solution set. So it says, express the compound inequality as two inequalities joined by one word and. All right, so let's see what we get here. -8 less than or equal to h minus 2 less than 1. All right, so the way that we're going to solve this is the same exact way that we would solving equations, not equalities, equations. And that is where we want to get the variable by itself. Now, the only difference is that in an equation, we have one equal symbol. Here we have two inequality symbols. So notice that I did it to all 3 sides, the middle, the right, and the left. So that is what I need to do equally to all 3 sides. Whatever I decide to do to one side will be done to the other 2 parts of the inequality. So I have -8 plus 2, that's going to give me a -6. We keep the inequality symbols the same way, because we did not multiply or divide by a negative number. And then 2 plus 1 will give me 3. I am done. Now, it does tell me here to write it with the word and. So I can write this in two different ways. I can go ahead and write -6 is less than or equal to h and, right? And I can write the other one. So the first one that I wrote is right here. I can write the other one where it's located right here, where h is less than 3. Okay, so I can write it in two ways. Here's one way right here. Here's another way right here, where it's separated by the word and. And lastly, I can write it as set notation, where I can go ahead and grab this one, which seems a little bit shorter to write in terms of h. It's the values that are greater than or equal to -6, but less than 3. Close set notation. All right, there we go. We wrote it 3 different ways. We wrote it without the word and, with the word and in set notation. And then lastly, how can we graph this? Well, graphing this is super simple. You want to focus on the two numbers that we have in mind, which is the number -6 and the number 3. The number -6 is the one that if you look at a number line, or imagine a number line, it's the one that's more to the left side, right? Further left. And then 3 is located at, so that's -6, 5, 4, 3, 2, 1, 0. This is 0 for context. 1, 2, 3 is located right there. Cool. So we want to do this in parts. Part number 1, let's go ahead and do this right here, where we could see that since we have an equal to piece, that is going to be a closed circle at the number -6. -6 is part of our answer. Cool. Next, it does say less than, I'm sorry. Whoops. -6 is less than, but h, or the solutions that we're looking for, are bigger than, larger than, greater than -6. So our arrow must point to the right. Cool. Done with that one. Now focusing on this one right here, where h is less than 3. So open circle, because we have an that symbol here without the or equal to, and less than means that we are going to the left. Now, where are the answers for this inequality? The answers that are in this inequality are located in the shaded region. It's the shared section, okay? The shared section only. So what I want to do right now to see if you understand where the answer is located is I want you to follow this yellow dot. Now, think about if this yellow dot is part of the solution. So right here, where this yellow dot is located, we could see that this yellow dot is part of the blue solution, the blue part, where it says the numbers that are less than 3. That yellow dot is definitely less than 3. It's right under the blue arrow, but it is not under the red section. So it is not part of our solution. This number, whatever number this is right here, this yellow dot, it does not solve the inequality, the compound inequality that we just solved right now, because it's not satisfying both pieces. It has to be both of them, because we have this very important word and. It has to be one and the other one. All right, now, what happens if I put my yellow dot right here on the -6? Well, let's talk about it. Is the -6 part of our solution? Yes, it is, because it's a closed circle. So -6 is part of the red one. It's part of the red one. Is it part of the blue one? Yes, I could see that my yellow dot is right under this blue line right here. So 6 is pretty good. Any number, or -6, sorry, any number that's inside of the green area is obviously part of our solution, because that's what they have shared. Now, here's the tricky part. What happens if I say the number 3? Does the number 3 satisfy the solution? The answer is maybe. Well, let's think about it. Is the number 3 under or part of this red section? And the answer is yes. But is it part of this blue section? The answer is no, because it's in the open circle. Remember that open circle means it is not part of that region. So on the 3, it would not be an answer. And obviously anything to the right of this will not be a solution either, because it's going to satisfy the red only, but not the blue. And it needs to satisfy both of them. All right. All right, here we go. Check problem. Stop this, try it on your own. Let me know. Here we go. All right, it says solve and then graph the solution set. Let's do this. All right, so for this one, go ahead and take the 2 to all sides so we can get rid of the items that are adding or subtracting. That's going to give me -9 right here, less than or equal to 3x, less than or equal to 5 minus 2 is 3. Cool. Now on the last part right here, we would divide all sides by 3, keeping all the symbols the same. We just divided by a number which is positive. All right, a -9 divided by 3 is -3. Now, that's something that a lot of students are asking. Mr. C, I thought we were supposed to flip the symbol because right here we're dividing and there's a negative number. Well, you are right. There is a negative number in that division, but the number that we are dividing by is not negative. 3 is not negative. It doesn't matter for the numerator. It doesn't matter that the 9 is negative. It has to be the one that's creating the division. So that is your answer right there. Once again, you can write this in another way. Where is -3 is less than or equal to x, and x is less than or equal to 1. There you have it. By using our little compound word and. We know that we can write this in set notation. I'm not going to do set notation because that should be already something that we know how to do. If you need more practice on that, make sure you go to the previous video. All right, here we go. The numbers that I'm focusing on is the number -3. Let's go ahead and 2, 1, 0, and then 1. I'll put another tick mark right there so it looks pretty, and there right there as well, just for whatever reason. All right, so right here in red, we have a closed circle because we have a or equal to. And then we have here our solution is more than. That's what it says. More than is always to the right. So there I go. And then here in blue, I have or equal to. That's going to give me a closed circle at 1. And then my solutions or my x values that are less than. Less than is always to the left. That is going to finalize this, giving me my solutions of the shared region, including, don't forget, this right here is a solution. Everything in green I already said, and this right here is also a solution because those are closed circles, okay? So don't count those out. Anything that is not part of the green is not a solution to the inequality that's a compound inequality. Now, yes, if I were to ask you, does this number satisfy the blue one? It will. It would satisfy only the blue one because it's under that line, but it doesn't satisfy both of them. All right, let's go ahead and see how we can apply this to a word problem. The most important thing about this is for you to read it yourself, and then I'll go ahead and explain it. But try to understand it, put it in your own words in your head. All right, here we go. So this question is talking to us about a cereal manufacturer that distributes cases of cereals to grocery stores. Now, when I read this, this is what my brain was kind of telling myself. At grocery stores, especially more, you see this more like in Walmart, like very large grocery stores, or Costco. There is the forklift that carries those large pallets. Those are called pallets, boxes. And these are large boxes that contain the smaller boxes of like cereal or granola bars or all these items. So when they say cases of cereal, I want you to think of this right here. This right here is a large case that has smaller boxes inside. Each case contains 12 boxes of cereal. So inside of this green square, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's going to be this right here. Okay. I know that cereal boxes are not round, but it's quicker to do it that way. In order to pass the manufacturer's quality assurance test, what that means is whenever there's a warehouse and they're making products and they want to ship the products and they want to take them to other stores, well, you want to make sure your products look nice, right? So your boxes are not getting squished and your whatever item it is that you have inside is not getting wrecked. Because face it, if you go to a grocery store, actually, if you go and buy anything, doesn't matter what it is, and you look at the box and it's like the box is crooked, broken, ripped, you know what we all do. We push that one to the side and we grab the pretty one. Okay, so companies want to make sure they don't have that issue. They want to make sure they sell everything. So they need to have quality control. All right, so it says in order to pass a quality test, the case, so this entire green box needs to weigh between that much and that much, which includes 34 ounces for the weight of the case's cardboard box. Ooh, so this green cardboard box that goes around all these little small cereal boxes already weighs 34 ounces. So, what's the weight of the case's cardboard box? Okay, so here's the inequality that we're going to create, all right, with the information that's given to us. So we have 12 boxes. We have 12 boxes of cereal, which we don't know the weight to. We don't know how much these blue these cereal boxes, which are cardboard, we don't know how much they weigh. So we need to use a variable there. Okay, what variable do you guys want to do? I don't know. Let's put W for weight. So 12 things that weigh the same. So 12 times whatever it is. But we also know that the green big box already weighs 34. Now, this weight needs to be within the range. It needs to be more than this smaller number right here, 331.6, and it needs to be between this one as well. It needs to be less than 336.4. So if you think about it, it makes sense that you want to make sure that your items don't weigh too much, because you're going to start crushing the boxes. The boxes will crush each other, right? So you don't want to make it too flimsy, so they don't rip and break easily, but you don't want to make them too heavy because they're going to be on top of each other or whatever the case may be. All right, now this is what we have. And now we just go ahead and solve. Now, the reason why Mr. Carreño didn't put the or equal to symbol is because there's a very, very, very important word that says between. The word between means you're not including those numbers. So if somebody were to ask you, think of a number between 1 and 10. If you're thinking about the number 10, you'd be wrong, because the number 10 is not between 1 and 10. It's actually part of your endpoints. So for that reason, I'm not putting my equal to symbol here. All right, so let's go ahead and take this sucker and solve it. Minus 34, that cancels out. Now on this side, I will have, let me make sure I am not giving the wrong numbers here. 331.6 minus 34 gives me 297.6. Oh no, what's going on, smartboard? 297.6. Symbol stays the same way. We have not divided or multiplied by a negative number. And then here we have 302.4, right? 336.4. I'm doing that thing that I know the answer, but I'm literally still putting in the calculator just so I'm not to make a freaking mistake. All right. There we go. Hopefully in this part, we already understand that we must divide 12 to every single side. Here, 12 divided by 12 becomes 1, and 1W is just the same thing as W. We didn't divide by negative 12, so our symbol stays the same way. Here, this value becomes 24.8, and this becomes 25.2. That's our answer. Now, we could write this if we wanted to with the word and, but that's fine. We don't need to. All right, now, really quick. What is this? What the heck is all of this? That has a story, guys. Don't forget that that has a story. I know that math to you guys is a bunch of letters and symbols that might not mean anything, but that does mean something. Look at the story right there. The story is, well, that for this company to pass the quality assurance test, each box must weigh between 24.8 and 25.2 ounces. That's it. If it's outside of that, if it's 24.8 or less, it's going to be too light. If it's 25.2 or more, it's going to be too heavy, okay, for what it is that they're looking for. So let's now turn this into a graph where I'm going to go ahead and put 24 right here. I'll put 25 right here. This is just kind of, to help myself out. That's not what I'm looking for. 24.8 located right there, and 25.2 located right there. Open circle for both of them, okay? And obviously I want it to be more than that, but less than that. And once more, our shaded region, our shared region is the green part. That's it. Very self-explanatory, very repetitive. Let's go to this next one. All right, so a compound inequality containing the word or is true if at least one of the inequalities is true. A union is the graph of a compound inequality containing or. What this means is, yes, we've already talked about and learned about the and inequalities. Now we're going to learn about the or inequalities. It's kind of like when your parents tell you, hey, you can go outside if you clean your room and do the dishes, right? That's one idea. The other idea is you can go outside if you clean your room or do the dishes, right? So the or one is a lot more flexible. The or one means, oh my God, that means I can just clean my room and then that's it. I don't have to do the dishes. Yeah, that's exactly what it means. So for example, look at this red dot right here. Right now, this red dot is definitely not a solution to what you see on the graph because it's not in any shaded region. Now, if I put my red dot right here or any of this blue part, this red dot will satisfy my numbers that are less than -3. Now, does this red dot satisfy the numbers that are greater than 1? It doesn't, but you know what? It doesn't need to, because as long as it's satisfying or it's the answer for one or the other one, it's okay. It is part of our solution. So let's go ahead and do an example just so you guys can see what we're talking about. 4n plus 8 less than or equal to 16. Now, the beauty of this one is that or problems are going to be very, very, very obvious. They literally have the word or next to them or in between them. And this just feels like completing two simple problems right next to each other. All right, so let's go ahead and start with this left side by taking 8 to the other side by subtraction. That is going to give us 4n less than or equal to 8 divided by 4. Cancel, leaving us with n is less than or equal to the number 2. Gotcha. Now on this side, we will take 7 by subtraction, leaving us with -3n. Symbol stays the same way. -18 is what we get here. Now on this step, we would divide by -3. The number that we're dividing by, which is the 3, is negative. So make sure you guys flip your sign. Very important. We flip our sign here. Now, let's go ahead and put our very, very, very important word, or, where our answer is n greater than, flip your symbol, 6. That's it. This is our solution, where this could also be written in set notation. If you're wondering how to write this in set notation, it'll look something like this. Grouping symbol, the variable you're working with, that little bar thing, close your grouping symbol. That's it. It's the part in red. All right, now let's go ahead and graph this to see what the solutions look like. All right, so I'm going to do this in 2 parts. I'll go ahead and do the red part, which was this right here, and the blue part, which will be in this one. Now let's go ahead and focus on the numbers first. We got the number 2, 3, 4, 5, 6. I'll put some tick marks here just so I can have it nice and pretty filled up. All right, cool. So a 2, we have our equals to. That's a closed circle. And it says my ends are less than. So my answers are less than. The shading goes that way. On this one over here is we don't have the or equals to, so that's an open circle. And my end numbers are more than. More than is always to the right. There you have it. All right, so this then becomes the question. What are the type of numbers that are my solution? So -547.32. The number 0, the number 2, the number 5, the number 6, the number 4 trillion. Okie dokie artichoke. And now I'm going to have a green dot. So the number -547.32 is located somewhere all the way over there. Is that part of our solution? The answer is, Is it part of the red? Yes, it is. Is it part of the blue? No, it isn't. But this word right here, or, makes this correct. As long as you get a number that is here or here, that will satisfy our inequality. So the number negative 547.32 is an answer to our compound inequality. Yes, it is. Now, what about the number 0? Where's the number 0 located? Well, the number 0 is located still within the red. And as long as it's within one of our shaded regions, we're good to go. What about the number 2? It's located in a closed circle. If it's on a closed circle, that means, yes, we're also including it on the red region. Now, the number 5 is located right here. It's not on the red, neither is it on the blue. So the number 5 is not a good solution, or it will not make the inequality true. What about the number 6? The number 6 is an open circle. Therefore, it's not under the red region, it's not under the blue region, so it's not neither. It's not a neither of those. And then lastly, the number 4 trillion. The number 4 trillion is located roughly right about here. You know, it's a joke, but it's going to be in the blue section because that line goes forever. And that would be some of the numbers that are that are true for your inequality, and the numbers that are false or not part of your solution set for your inequality. All right, moving on. 5x plus 1 less than 11, or negative 3x plus 10 less than or equal to 11. All right, on this side, I'm going to call it the red side. We're going to take away 1, cancel, cancel. We now have 5x less than 10. And then lastly, divide both sides by 5, giving me x is less than 2. Our symbol here never flips because we never divided by or multiplied by a negative number. Here, we're going to go ahead and take 10 to the other side by subtraction. That will give us negative 3x less than or equal to negative 21. And lastly, divide by this negative 3. What do we notice? We notice that we divided by a negative. So we got to make sure we flip the symbol. What's your final answer? Our answer is x, flip my symbol, is greater than or equal to 6. Boom. Okie dokie, artichoke. What do we got? The number 2, 3, 4, 5, 6. Did I just do the... Why does it look so similar? 4n plus 8. Huh, okay. I'm having deja vu. What do I feel like? Did we get the same type of answers? Oh, well, here we go. At 2, I'm going to have an open circle. And my numbers that are less than 2 are going to be that way. Shade, shade, shade. In green, it's a closed circle. It's the numbers that are greater than 6, which is that way. And there we have it. Oh, this is the same type of thing. But literally the circles are just are the opposite. All right, guys, I believe, yeah, we're going to stop right here this video. The next video is going to start with example number 4. Peace out.